This one goes out to Chai Ann. She asked me for a video on how to do polynomial long division. Don't worry, I got this. It's not that bad. It just looks really weird and confusing, but it's not. So check this out if you get bored, or maybe if you just secretly enjoy my videos. Either way, here we go. Alright, so what is the deal with this polynomial long division? So I've kind of just written something down to get you started on the idea. It's the same as the long division you already know. So I'll show you a basic example of long division, and we're going to translate that into two examples using algebra. Okay, first things first. 6 goes into 365. The first thing that I would try is, okay, does 6 go into 3? No. So I will move on and try and use both of these numbers. Does 6 go into 36? Yes. It goes in 6 times. Okay, so then I go ahead and do 6 times this number to get 36. At this point, do I go ahead and add these two numbers? Well, maybe on a technicality you could say yes, but what I really need to do is change this sign. I'm trying to get it so that things are reducing. Well, I have to do that even here. So I need to change the sign of this by throwing the negative in there. And now I can write this as 0, bring down the 5. And then I ask myself the same questions. Does 6 go into 5? No, it doesn't. So I would put a 0. And I could do 6 times 0 is 0. So here's a 0 here. And yeah, I would go ahead and subtract this right here. 5 take away nothing is just 5. So this is a basic example of the long division you already know. I've got a remainder of 5. So my full answer to this problem would really be 60 plus, I'll take my remainder and put it over this number. My remainder and put it over that number. Okay, so I could write it like this. I could also represent, when it's just numbers, I can also represent it as 60 and 5, 6. You can put them together without the plus sign, and these two things are the same. Okay, so what we're going to be doing here in this example is essentially what we just did here, just with some algebra. All right, so take x squared plus 9x plus 14 divided by x plus 7. Okay, so first I'll write x plus 7 out here. I'm going to divide this. I'm sorry, it's going to go into, my bad, x squared plus 9x plus 14. I have some extra space here in case anybody wants to snuggle up next to the 14. You are more than welcome to do that. Yeah, I just made that too big. I don't know what I'm talking about. Anyways, so a couple of things you want to make sure that you do before you start. First of all, make sure you have all these terms filled in. What do I mean by that? Well, say this was x to the third and it dropped right down to x. You want to fill in the x squared terms with a 0. But everything is good here. This is x squared. This is x to the first. This is technically x to the 0, so that's fine. So x squared, x to the first, x to the 0. Everything is here. Everything is accounted for. In the next example, I'll show you what happens when everything is not accounted for and what to do. But we're good to go here. So what's my objective? The first thing I'm going to do is kind of cover up with my finger the plus 7, the minus 7, the plus 80, the minus 56. Doesn't matter. I'm just going to have the x. And if there's like, 2x or 2x to the fifth, fine. Just get the x term for right now. How do I take this x term and make it look like this right here? Well, to go from x to x squared, all I'd have to do is multiply by x. So now I can go ahead and do that just like I did up in the other example with long division with just numbers. Now we start multiplying these things. What's x times x? It's the x squared that I wanted. What's 7 times x? Well, it's just 7x. Now, do we go ahead and just add straight down? No, we have to change the sign just like we did when it was just numbers. So when I change the sign, I'm going to throw a minus sign here. That's going to take this x squared and make it negative. That's going to take this plus 7x, and it's going to make this one negative. So I'll change my sign kind of ghetto like that. It's okay. Don't tell anyone. You won't tell, I won't. Now I can go ahead and start adding these things. X squared minus x goes away. It's all gone. Then 9x minus 7x gives me 2x. So all I have to do to continue this process is bring down the 14. So 2x plus 14, and then I just do this all over again. Cover up the 7, and I say to myself, what do I have to do to this x right here to make it look like 2x? Well, that's pretty easy. Take x and make it look like 2x. I just have to multiply it by positive 2. So x times positive 2 is now 2x. 7 times positive 2 is now plus 14. Do I go ahead and add these straight just as they are? No, I don't. Before I have to do anything, I need to go ahead and change my sign. So if this is positive, I'll make it negative. This is positive. But that's okay. Make that negative. Okay, so 2x take away 2x is 0. That's gone. 14 minus 14 is 0. So everything here went away. I'll draw a Joe right there. So Joe Cool's right there representing that there's no remainder. And yeah, this problem is done. So the way that you could write the answer is simply that the division that you get out of this, the answer is x plus 2. Got it. So, maybe you could have something in front here to say, okay, this, all this, when you divide them, you just get that. That's fine. So essentially, this is one way to factor. Yeah, there's a huge, long list of ways to factor. So this was a pretty simple example. We got no remainder. Things were set up for us really nicely, x squared x. Let me show you what happens when things not quite so nice in the next example. Okay, here we are. Second example, there's more to do in this problem. So what we have here is 4x to the fourth plus 3x to the third plus 2x plus 1 all divided by this. Okay, so I'm going to go ahead and write this out. I'm going to take this and divide it by this. So this is the part out here that's going to go out in the front. All right, so x squared plus x plus 2. And I'm going to divide this into, hopefully that's not way too long again, who knows what she said. Anyway, so 4x to the fourth plus 3x to the third. All right, so it goes right from x to the third right to x. So what is missing from here is an x squared term. So I'll go ahead and add that in as plus 0x squared. Important that you do that because if you don't have the missing terms filled in there, you could mess something up and get the wrong answer. So if there are any terms missing out of here, add them in as 0x squared. So essentially we haven't changed this. We've just made it so that we can see this and hopefully account for that in our division. 0x squared plus 2x, so 4, 3, 2, 1, and then plus 1. Okay, now this is perfectly set up so we can start. And so to start this, what I'm going to do is the exact same process as the first one. I'm going to cover up everything else except for that very first term, x squared. How do I take x squared and make it look like the very first term here, 4x to the fourth? Well, first of all, I can multiply it by, for sure, 4. I need that. That takes care of getting this to have the 4 in front of it. How do I get x squared and transform it into x to the 4th? Well, I can multiply it by x squared. So in grand total, I need to take x squared and multiply it by 4x squared to make it look like this. Okay, here we go. So once we do this, we'll start multiplying all of these terms by this. First one's going to be 4x to the 4th. That's what we wanted to happen. If you don't get the same thing that you got here, you did something wrong. You want things to start canceling. Okay, this will become plus 4x to the 3rd. And 2 times 4x squared is plus 8x squared. So if you don't have that term there, you're going to write this and be like, where do I put it? Nope. So anyway, you have that in there. Everything is lined up and looks good. Now, I can't just add these up here. I have to change all their signs. This one becomes negative because it's positive. This one, it's positive, so I'm going to change it to negative. This one, it's positive, so I'll change that one to negative. If some reason they were already negative, you would be changing them to positive. So here we go. Now I can go ahead and add these up. These cancel out, and I can do this. Now, 3x to the 3rd take away 4x to the 3rd leaves me with a negative x to the 3rd. And what's 0x squared take away 8x squared? Minus 8x squared. So I've done the subtraction, and now my next step is to bring down. So I'm going to bring down this plus 2x, and then I'm just going to repeat this process. So I'll cover up these things here, just leave the very first term, in this case is an x squared. How do I take x squared and make it look like a negative x to the 3rd? Well, first of all, I need to make a negative. So there's that. The second thing I have to do is take x squared and make it look like x. So probably, take x squared and make it look like x to the 3rd. So if I just multiplied x squared by another x, I would get to x to the 3rd. So I've taken care of the negative with this and multiply by another x to give me x to the 3rd. All right, here we go. So I get negative x to the 3rd, which is exactly what I wanted. Remember, if these two are not the same to start off, we didn't do something right. You want things to cancel. Okay, plus x times minus x is minus x squared. And 2 times a minus x is negative 2x. Okay, can I go ahead and add these right now? No. First, change their signs. This one's negative, so it becomes positive. This one's negative, so it becomes positive, and this one as well. Now that all the signs are changed, I can go ahead and cancel those out. They do cancel each other out. Negative 8x squared, add another x squared, you get negative 7x squared. And 2x plus 2x is plus 4x. Okay, here we go. Bring this down. This will be the last time we bring that down. And now that that's done, I'm going to do this process for the last time. So how do I take x squared? Remember, I'm ignoring this other stuff right now. I don't have to cover it necessarily with my finger every time, but how do I take x squared and make it look like negative 7x squared? Well, if I multiplied it by negative 7, that would definitely do the trick. So then I just start multiplying all of these terms and write it underneath. Negative 7x squared here, negative 7x here. Oops, sorry, I kind of lost sight of what I was writing. And then negative 14 there. Okay, so I have all of those done. Can I add them yet? No, I can't. I have to change the signs first. This goes to positive, that goes to positive, and so does that. Okay, so now that I've changed all the signs, I can go ahead and just add straight down. These cancel out. That's exactly what we wanted. This goes to 11x, and this goes to plus 15. Okay, there's nothing more to bring down, so I stop here and I say, well, this is my remainder. There's no more Joe Cool for this one. So me, being Joe Cool, the actual identity of Joe Cool is me, I'll show you what to do with this remainder. So your answer to this division problem is essentially, we can write it as, I'll come up here. Here's my answer for this division problem. It's 4x squared minus x minus 7, so the stuff that we got here. And then see how my remainder started off as a positive 11x. I'm going to go ahead and transfer all of this stuff up here. So I'm going to go plus 11x plus 15. So I just take whatever my remainder is, add it onto here, and with one small addition, just divide all of this stuff by this original part right here. X squared plus x plus 2. And this is the final answer for this problem. So this one kind of showcases pretty well how to do long division. It's got stuff you got to fill in. It's got a remainder. You've got, you know, some negative stuff to worry about here, and you've got more than just a linear term that you're using. So I really hope this helps. I know long division can be tedious, but it's not difficult. There's nothing about anything that I've done here that really goes beyond Algebra 1. It's just using the concepts you know from Algebra 1 and applying them to this Algebra 2 type setting. There's nothing here that's actually that bad. I hope this helps a lot. Please leave me some comments and suggestions. I'm sorry this video went a little longer than 15 minutes, but I feel like this was a good example, and hopefully it helped you guys. Thanks for watching. Bye.